All right. Next up, we're going to be talking with Michael Kohler, Matthew Ward, and Omer Shapira on is the network is fast enough? Question mark. I'm going to let the team do deeper introductions. This is a really great group of speakers who are going to be discussing the topic with you today. So let's bring the gang in. Welcome, guys.
Hey, guys.
Hello.
Hey, Laura.
Yeah, good
Hey,
to see
Elliot.
everybody.
Excellent. Yep.
Hey.
We'll hand the floor over to you.
Yeah.
Thank you for being here today, and we're very excited for your presentation. So over to you.
Okay. So I'm going to introduce Michael and Omer. Michael went to the University of North Carolina School for the Arts. He's a technologist, a systems architect, and a computer expert. As a media server programmer, he has traveled around the world on various theater, television, and corporate productions, and enjoys spending his free time playing video games with his cat. I'm only surprised there's just one cat, honestly. As the head of R&D at WorldStage, he's responsible for seeking out new technologies and infrastructure and exploring new technologies, new applications. Omer Shapira studied mathematics at Tel Aviv University and digital art at NYU. His works span virtual reality, human-robot interaction, large-scale simulation, haptics, broadcast technology, and autonomous machines. No cat mentions so far. Over the course of his career, Omer has been director of VR at Fake Love, RIP, VR developer at Framestore, and an editor and director at Channel 10 in Israel. In addition to being an artist and researcher, Omer is currently a senior engineer at NVIDIA. My name is Matthew Ward. I went to Hampshire College, where I studied how to get credit for producing punk rock shows as an academic. I went on to found Techamaki and Element Labs. I think video is the best way to program and control light. I currently split my time between WorldStage and Superluminary, where I do consulting and design display-driven hardware for people. So we're here today to talk about communication and collaboration, about networks and speed. We've had switches and routers on shows forever in kind of a balkanized way. Dante for audio, network for the media server people, the LED crew talking to LED walls over a network, ArtNet and WDMX for the lighting folks, Wi-Fi for production folks, and hardlines, as Kirsten was discussing, for the massive downloads of late arriving content. We also have SDVOE, SMPTE 2110, NDI, a lot of movement onto the network, but utility like this always precedes broad adoption. All these things are out there, they don't all fit together. And we've been making that assumption that they would fit together on some sort of Uber show network. We start this session in a land of shadows and substance as we cross over into the early days of COVID. And Michael's going to tell us about the seamless transition to the cloud. So, Michael?
Yeah, seamless is one way to put it. I think I was sort of in the same boat as Kirsten and some of our other presenters who were sitting there watching their worlds crumble around them and thinking, okay, now what? So from there, I spent some time looking at different technologies, different things that were interesting. What am I going to do with my life? Should I study some more IT stuff? And then I got a call from the folks at WorldStage, and they're like, hey, we need you to go learn AWS. And I'm like, you mean like the Amazon thing? And they're like, yeah, we want you to build a live video production system that exists entirely in the cloud. So, okay, I knew vaguely what AWS was, but had never experienced anything to do with it at all. So I started where I start with everything, and that's spending about a week watching YouTube videos, figuring out what on earth AWS is and how we can possibly mangle it into doing what we need. So, like all first attempts at everything, like I just started creating a bunch of resources in the cloud, turning things on, seeing what worked, breaking things, charging way too much money to certain projects by mistake. Thank you to our, as Laura said, Amazon Web Services doesn't work on love, they work on cash. But occasionally, if you screw up big enough, they will remove some charges from your bill after the fact. I accidentally turned on a really expensive machine. But ultimately, what we determined during that early on research period with me and our sort of ragtag group of people who were working on this was that the cloud's a lot better than we thought it was going to be. I had read a lot about VDI, which is virtual desktop infrastructure, and you hear that term used in a lot of animation and art studios that are moving their entire animator workflows into virtual cloud-hosted workstations. And when I first read about this, I was like, there's no possible way this could be usable. It wouldn't be fast enough. I'm not going to like this. So I spun up some instances that had big NVIDIA GPUs in them running their grid software, which allows you to use the displays remotely. And I was able to get the system into a place where I had a virtual machine in the cloud that had two 1080p screens running at 60 FPS. And, I got to this point where I was like, okay, so let's really see what this can do. So I installed Disguise on it. And this is absolutely not what they wanted me to do from work, but this was sort of my way of benchmarking the performance of the system. So I took a program that traditionally resides on, big powerful servers that are under my desk and put them in a data center somewhere in Virginia. I'm actually not allowed to know specifically where they are because that's a security thing, I guess. And Disguise ran pretty decently. The latency to my connection was wonderful. I was able to interact with it. I could even send USB devices to and from the cloud through remotization. So I was able to get the dongle working, which is obviously the most important part, but also other fiddly gizmos like Stream Decks and stuff for other projects. But ultimately, after doing that, we're like, okay, we can totally make this work. We spun up a studio and we basically gave everybody their own workstation. And we learned that that's absolutely not the way to do things, because once you give a bunch of people computers, they just kind of move in. And while that's wonderful when you're near the computer, the cloud is a big, scary place and the internet is a big, scary place. And sometimes things fail and disappear. I mean, always things fail. That's really the rule of the cloud. You have to design for that. So we did a few shows like that and we learned a lot, and teaching people how to do their jobs remotely could be a subject of an entire different conversation. It's just, there's so many other factors at play. And as an architect, you want to minimize those disruptions and problems. You really want to think about what everybody needs in order to do their job. And one of the things one of our audio people came to me with was I really need faders. I'm like, okay, I have this USB remotization thing because I wanted to play with D3. Here's your USB Akai little mixer console, and now you have faders in the cloud. So while we were everybody was running on their own machines, we actually re-architected the entire system out from under them because we needed to start dealing with security and scale. So Amazon has this concept called VPC, which is the virtual private cloud. And what we ended up doing is creating this concept called a control room. And I guess most of us are familiar with what a control room is, but in the cloud, a control room is basically a collection of virtual instances or computers. And every computer has a function. It's maybe playing back video, maybe it's running PowerPoint, maybe it's running Keynote, maybe it's running video mixing software, maybe it is a software that a file manager would log into and just shuffle files around in S3 all day. And over time, we realized all the different jobs people would need to do in order to do the job that they were previously doing backstage, now from the comfort of their home. And we recreated all of those workstations in the cloud. We have QC monitor systems that are based on a low latency video streaming technology. So we actually take the NDI feed of the multi-viewer that's generated internally in our system and display it over the web to the show callers so that they have a low latency preview that they can actually watch along with the show and still call cues reasonably. Nothing is perfect. There's always latency. And the one thing we quickly learned is that the closer you are to where your stuff is hosted, the better it gets. So that's one of the real benefits of using Amazon Web Services, because they have resources everywhere. And that gets me kind of to my last little point here, which is the hardest part of all this, of course, is always the last mile. And, in the cloud, bandwidth is effectively unlimited. We're going to talk a lot about, some of the new technologies and things that make the network fast enough. But the reason I put a question mark at the end of is the network fast enough is while all these machines may be able to communicate with themselves quickly enough, once you start bringing individual people in and, screen sharing and sending their video up into the cloud, you're at the mercy of the public internet. And there's ways to mitigate that. And, there's a lot of work being done with redundant cellular connections, VPNs that traverse you through certain higher bandwidth portions of the internet and allow you to route around problems like that. But there's this whole feeling constantly when I'm watching any of these things go on is like anything could stop working at any moment and I'll be largely powerless to deal with it. So, with the presenters, that's one thing. You want them to have as reliable internet as possible. Like, I'm here, I'm plugged in, obviously. I'm trying not to have a too bad an internet connection for a framework. So hopefully that's working out okay. But for the technicians, you also have to think of them as, when you're doing a show, you have 2 racks of computers. You have your main system and your backup system. And if the main system goes down, you fall over to the backup system. Well, we kind of need to extend that metaphor a little further into the operators, because at any point in time, they could fail. And it's not that they have any real problems. It's just that their connection to the cloud maybe went away. So
always redundancy.
Yeah. So at this point, there's this concept of redundant operators as well. So people are kind of like watching over the shoulder of the person switching the show. And in the event of an unlikely internet emergency, perhaps somebody else can go fill that person's shoes while they get back up and running. So there's a lot of gotchas that we learned about doing production in the cloud really quickly. But we feel that the quality benefits that you get from having a primarily cloud-based workflow really outweigh some of those negatives. I mean, for like graphics and video playback, that stuff is hosted in the cloud. It is played back in the cloud. It goes into our switching infrastructure in the cloud. It never has to go over the internet, which means we don't have to deal with compression, artifacting, glitches, with that sort of stuff. It is much, much, much more reliable to keep that stuff on Amazon's very expensive network that we pay good money to use, rather than, somebody's home Wi-Fi. They start their keynote deck of videos playing, and all of a sudden, one of their kids logs into Hulu or Netflix, wants to start streaming a movie, and all of a sudden, Zoom takes their compression. All of a sudden, you're 360p and blocky.
Yeah, no, we hear a lot about that in terms of people having a time of day where they functionally can't do work internet because all the kids in the neighborhood go on school. So it's not even the one house. It's, a node remote from there. But we go from basically technicians collaborating to a larger question. And Berto, this came up in, I think, the All of It Now talk, where you had a lot of different people collaborating on just the creative and the content ahead of this. So what we're talking about in terms of doing a show live is the very last moments of this production process, which goes back to a lot of other talks. So what are we doing in the cloud? And this is sort of a throw to Omer. What are we doing in the cloud in terms of collaboration at that level and delivering these shows with more distributed workflows?
Yeah, and I guess like a lot of people in during the pandemic are expressing the opinion that they're learning to not fear the cloud. I kind of had the opposite experience in my, at least in my professional career, that I learned to fear the cloud pretty much midway through, and the reason is like starting off. One of the first places that I worked in, which gave me the most confidence that these things are indeed possible, hosting is indeed possible, it was Channel 10 in Israel. Was a small, it's no longer called Channel 10. It was a small studio, relatively small, second in size in Israel, and had a massive investment from Avid Technologies. And the investment was in media servers. So basically anyone coming in, and this is 2006-ish, anyone coming in could pull video into their own machine to edit with, which is rocket science back then. But it gives, after a while, the master control room people started getting enough confidence in this so that when you're running a news show, you didn't have to run with tapes, right? You would actually play things from a server. And you would do this we had 2 studios, one in Tel Aviv, one in Jerusalem. You could edit remotely. And I'm not saying it was super fast, but like overall, you saw where the technology was heading. And coming back to like after a break doing engineering, coming back to broadcast technologies, I noticed that people have stopped trusting the cloud. I didn't understand why, and it turns out that actually the internet infrastructure in America is not amazing. And in many places you kind of don't have a choice but to to have everything local. So people are very much used to having their old set of tools. Everything in the studio has to run through SDI and so on. And I think that there are some misconceptions that we can change fundamentally with that. So the first one is like when we talk about cloud, we're talking about three different things, right? We're talking about bandwidth, as in like throughput, and latency. Those are the familiar ones, right? Like how much information I'm sending and how late am I sending it. But there's another issue that people couldn't work with, which is timing, right? And up until now, when you were working on a production, you were kind of at the mercy of like a master clock, and each studio has a master clock. And because you have a master clock, you have to be working locally. Everyone, if you're playing in a band, you have to listen to the click track, and you have to listen to everyone playing, and those kind of are coupled concepts. And I think that reality in particular is changing because we are getting, like Mellanox has very fast Ethernet cards now, and we're, the network itself, Europe right now, the kind of latencies that you'll get is like 5 milliseconds over 500 kilometers in terms of like, studio spread. But the most important thing is that people can synchronize within themselves. And that's something that we didn't have until now. But some people had it, like high frequency trading firms had it for a long time. This is a tech called precision time protocol, which is, it's being used widely around the world, but mostly in places that broadcast technologies have not heard about. And the advantage is, of this technology is becoming a lot cheaper. Basically, what you do with a precision time protocol is you have one clock that's somewhere in the world, and you have very precise hardware listening to that clock, and it's propagating that into every part of your computer, right? So computers can be very specialized to do things like listen to a time signal and do an operation just at that time signal. Hardware is developing to allow that. Computers up until now weren't really designed for this kind of processing. You wouldn't interrupt a CPU to do something from the network. Well, now everything that comes in from the network has a very accurate timestamp if you're using PTP, and it also can go directly into your GPU, so you have very little latency, right? And those two things together allow you to do pretty interesting productions, because on one hand, you are all the computers are listening to the click track, so they know exactly when things are happening. And they can also, they can synchronize on, like they can with confidence send a frame of video through the network, knowing exactly when it gets played. And if you are a literal musician, you'd be like strumming your guitar and know exactly when it's hitting because you are listening to that click track, right? And so those are huge advantages. And what we are trying to do as, like a company that powers a lot of cloud things, power cloud graphics, is push the PTP adoption anywhere that we can have it, right? Because timing is something that we can beat. We can actually get very accurate timing if you have like a GPS that's listening to atomic clocks somewhere. We can't always solve latency, right? People often, that when they work with PTP, they get so much confidence that they think they can break the speed of light. They can break the laws of physics and say, oh yeah, these frames can be running at the same time. So that's always a problem, There's like 5 milliseconds over 500 kilometers ish, or something that you can't really break that well, but you can schedule things. And so a lot of the multi-studio collaboration technologies are based on that idea. All of the tools that we're going to be building are going to be using multi-studio collaboration with accurate timing in advance. Now because we're running out of time, I can show a few things that we've been working on. I'll try to be quick. Is that okay? Can we do this now?
Yeah.
So
No,
let me share
and
my
the
screen.
interesting thing about PTV is obviously it's in every GPS product or pretty much, but it's also the thing that makes all of the cellular antennas work. So this is already a highly distributed, accessible tool.
Yeah. And so can people at home see my screen? I hope so.
I hope so.
Yeah.
I have no way
Yes.
to know.
Yeah, we
Okay.
got a
Yeah.
thumbs up.
Okay, so yeah, in general, if you're running a studio collaboration remotely, one of the most crucial things that you want to hit is make sure that everyone has their tools interacting in time. Now, it used to be that in a like studio environment, if you wanted to have like a very well traced, like ray traced scene, you could be using any of these tools, right? Like any of these tools can be feeding into a rendered scene, Unreal Engine, Revit, Substance Designer, Unity, whatever. But if you wanted to do anything special to that scene, for example, add hair effects or smoke or things like that, you needed to use a combination of other tools, and those would be feeding in to other artists, and they can't be collaborating that way, really, because that means that if I want to change like a tip of the vase in one of my models and then move it back to a texture artist and then move it to a physics person simulating it until it hits the render, it's a day, right? And so we created the system called Omniverse, which allows all these tools to connect at the same time. This is a great advantage because it means that you're not only working remotely on your project, everyone is using the power of their own desktop, right? So I can be running Maya at home or Unreal Engine at home, and still enjoying all the benefits of the network, receiving updates from everywhere else. Every tool can open this kind of workflow. So right now we've been testing this with Houdini, which has support for USD, which is the platform we were using. We've been testing it with Unreal Engine, and let me show you a little bit what that looks like. So this is a test that we did with between a few studios. We ran like a studio in Los Angeles, like one of our people was in London. I don't think this is actually Bangalore, but this is conceptually Bangalore. And like the Bangalore in the heart.
Meta Bangalore.
Yeah, and we have people editing. These are different recorded sessions. We had people editing the same scene with like our own renderer, with Maya, with Unreal Engine, all collaborating together, and this is happening in real time, right? So that's a sort of advantage that you get when people are really in sync. Since we're short on time, I think that I'm going to show a final result of one thing that we made working this way, and then we can switch into questions.
Yep. No, it makes sense.
I think just watching the collaboration happening in real time, sort of one of the questions I would have as more of a live person is, how can we petition the software programs that we use to work with NVIDIA, or like what's the process to get a piece of software that is currently not Omniverse aware to actually work with it? Because this seems wonderful, but
so the basis for all of these tools is universal scene description. It's a software, like it's a framework that Pixar made specifically for collaboration. If your tool supports universal scene description, it can support Omniverse. That should be your basic frame of mind there. Universal scene description has a lot of reasons to be adopted. It's a highly collaborative file format. Every major tool has announced support for it. It's already in like making progress. I think last SIGGRAPH there were 18 renders that supported it. So that it's already doing great. By the way, what I'm showing you right now is something that we developed entirely during the pandemic. Can you see my screen? So we developed this entirely during the pandemic. This is all film-grade assets running inside Omniverse, where all the artists were remote, which is a very common thing at NVIDIA. And this is running on the the framework that we had with our own render, which supports dynamic lighting. The advantage that you have working this way is that I I could want like when a material change, and one of the material artists is indeed in San Francisco, for example, and they could be editing this material live, and it would just show up in the scene, right? So this makes virtual production and online collaboration pretty much a breeze. Yeah. Are there?
No, so this could be interesting in terms of. Then we should probably throw to Laura and Elliot for questions. But this is the sort of thing that could be very interesting in previs, where you're looking at the carbon demo we got yesterday and looking at how a tool like that could be used with people spread over 5 different time zones and in different departments dealing with different aspects of a show.
Yeah, and so this is not necessarily just previs. I mean, like, this is definitely capable of previs, but these things are, like, we have the speed to make this run live, right? And that's the one of the mental adjustments that people have to make, is that, like, all of the industry now can do these things live, as in run the show live.
Except for clients, right? Except for clients.
Yeah.
I just want, right?
Yeah, I mean, sure. You have to put these things. Yeah, the GPU has to live somewhere, and it can live on the cloud. It can live in the studio, and then you have you're at the mercy of the internet to deliver it to the last mile. But this is a very simple last mile equation. Like Netflix have solved it.
Yeah.
I'm not gonna degrade their work, right? Like, it's a complicated last mile equation, but it's a relatively studied one.
Excellent. This is
Excellent.
going to transform how we work.
Media servers in the cloud. You heard it here first. I'm ready for the future.
We wished for it all summer, and now we
Okay.
have it. So, or it's coming. So thank you all. I think it's a really exciting, the kind of information you're presenting is very exciting to think about its impacts to our future. And it's wonderful to be able to kind of digest with you guys, like, how this will impact our live events work. I mean, we can see its impacts to, film effects work and that pipeline very quickly, and the way it'll trickle down to live events. I think we'll be up to Mr. Kohler.
We'll see.
At least help us get it started. So maybe we should jump into a couple of questions, because we only have a few minutes here. We have a question from Brett Dykus in Kansas City. He'd like your advice. What platform servers are you using for low latency multi-view monitoring?
Yeah, I can take that one. So in order to do that, Amazon acquired a company called NiceDCV in 2017, which is a remote display protocol used for getting engineers and architects and creatives access to their workstation in the cloud. And we sort of found a way to use that in ways it was not intended to, because it actually has a web server built in, so that you could log into one of these remote services over the internet. So basically, we're running a handful of these machines in the cloud, and we provide login information to the show staff for those machines on a show-by-show basis. And the people who need access to it can log it in, and we're kind of monitoring it to make sure that we're not using too many resources or have too many connections. But it basically just sits behind a load balancer, and from the production end, we figure out how many people need to be watching the multi-viewer and just build the resulting cluster as we need to.
Fantastic. I think
We'll jump to our next question.
we got one last one. Andy Babin asks, what benefits do you see hosting in the cloud AWS versus self-hosting? Money? ? Ability to spin up resources quickly, physical redundancies.
I mean, I think you've got you go.
Oh, sure. So I think the biggest advantage in terms of putting things on the cloud is availability, right? And availability sounds like a user thing. It's also a production crew thing. You want everyone to have good access to your to the servers or to their tools, and by putting this on the closest thing that you can to the user, maybe even it's a data center that's on the 5G tower, that's totally an option nowadays. Then you have a very good access to like the people doing the production. The users don't really mind if they receive it half a minute late. Honestly, the most important thing in cloud hosting is actually just the creators.
Great.
Yeah,
I think we can sneak one more question in, and then we'll probably have to wrap up. So I want to get this one last question in from Alex. Does universal scene description support textures, animation, rigs, simulations, etc.? I'm curious what the limitations are from a 3D software standpoint. In other words, do you have to bake stuff?
Do we have another half hour? So the short answer is yes.
Over on Discord afterwards, where everyone can talk for as long as. Yeah.
So the short answer is this is all a matter of implementation, right? The format was built for collaboration, and it was built very much with Pixar's problems in mind when Pixar built it. Fortunately, right now the entire industry is collaborating on universal scene description, and they're adding all these things, right? So universal scene description allows you to bake things just great, and this is what you do when you're visualizing AR on your iPhone. But when you're working in collaboration, you have textures that is built in with USD. Many materials are supported to be in encoding in USD. So, for example, Houdini have their own material system that lives inside USD. We have our own called MDL, Material Definition Language. It's open source, so you can use that. And there's many tools that are working on feeding frame-based information into USD in a manner that I wouldn't call baking. So you can be sending raw data and doing the processing locally, or do the opposite. I would like to think about USD pretty much like I think about Git. It's not what you interact with, it's what your program interacts with. So a lot of things are achievable in USD if your program does the right thing to optimize for that. And like the programs that I've seen, I'm very optimistic in what they can do with simulation locally and real-time workflows.
Well, it looks like we have a great platform to explore USD in future discussion, but for the meantime, please look for our speakers, hop in with your questions, and we look forward to future conversations with you on Framework. Thanks everyone for being here today.
Thank you guys.
Pleasure.
Bye.